Gusto, we can't hear through these doors. All right. How has this one been moved? Easiest way to tell on that is to find the vertex. Hopefully that word's not totally new. The vertex on the blue one, that very bottom point is right there. I'm going to make it blue, in fact. Let's make it blue. And on the orange one, it's right here, this bottom piece. So the easiest way to tell how it moves is to track the motion there. So this has gone left, 1, 2. So it went left, 2, and it went down, 1, 2, 3, 4. Down, 4. If we think about our A, H, and K from yesterday, when we had our A with whatever our operation is, X minus H plus K, which one of those is going to tell us about left? A, H, or K? H. So this one is going to be the H value. And it's going to be, since it went left, -2. Then we have our K value, or down. Oh, I wonder which one it is, since I totally just slipped and said it. Which one tells us about down? Okay. Yeah, -4 is going to be our
H. Okay.
K. We already have H. K is our vertical. That's our kite. Whenever we're reading these off a graph, I am never, ever, ever going to have you spot an A change. Never, ever. They're very nearly impossible to calculate by looking. Okay? So if we're just reading a graph, there is no A change. So we could write this as the equation x minus -2, minus negative becomes plus 2, plus k minus 4. So that's kind of the generalized transformation. Ideally, we'll notice that this is g of x equals. And ideally, we'll notice that this is a U shape, not a V shape. So that means it's an x squared. If we just get the -2 and the -4, that is a gigantic chunk of it. If we catch the notation, fantastic. But noticing the H and the K is the big part of it, okay? Finding the pieces, how it moves from that middle. Questions on this one? They're a little weird. It's one of those things that pops up, especially on Alex and on stuff like that.
How do you know it's squared?
Because it's a U. Because our shape is a parabola. This is how an x squared looks. So if it's U-shaped, it's got a squared over your parentheses. If it is V-shaped, that's when we have our absolute value bars. And at this point, those are going to be the only two we show you. We're going to play a lot with x squareds over the next 3 months. Thank you, dear. So we are going to play with x squareds a bunch. We're not particularly calculating them right now, but just noticing the difference between a V shape and a U shape. U shape means we put the squared. V shape means we put the straight lines instead of the brackets, or instead of parentheses. Heavy graph strip. Here's our graph strip today. That's 2 copies. There we go. So we're going to try this again. And again, we're going to go with that important point in the middle as kind of our way to figure out what's happening. So on our absolute value, we're going to take the bounce point. And then on our transformed function, we're taking, again, that bounce point. See how it moves from one point to the other point. That's going to give us our H and our K. And it doesn't matter what order we write them in. Because for my brain on this one, I want to go up first. Up, 1, 2. This one went right 1. Up 2 tells us about which term? AH or K? K. So my K is going to be positive 2. How about the right one? H. And my H, since it went right, is going to be positive 1. It's V-shaped, so we're going to use our absolute value. So we're talking about the green one, which is G of X is absolute value bar X minus H, so X minus 1 plus K, 2. X minus H plus K. So on the back of homework 7, it has problems very much like that. Find that important point, the bounce point, the vertex, however our brains are thinking about it. Always looking for that bottom point and how it has shifted from the origin, from that 0, 0. Okay? Because what we're going to do with those last 2 graphs is we are going to practice the AH and K graphing that we kind of started yesterday with the real simple ones. These ones, like, it looks like we look at that and we go, whoo, that's kicked it up several notches. But it's okay. It's all the same pieces. I'm going to make it so you don't follow my weird zoom-ins. There we go. So this is when we're going to take our transformation form, AX minus H plus K, and we're going to identify our A, H, and K pieces. A equals H equals K equals. I want to find those pieces. What do we know? What's one of these pieces? H is 1. And H is positive 1. We even caught that sign. Good job. What else do we know? K is negative 2. And A is 3. Oh, good. The highlighter went normal. Sometimes if I do it in 2 tries, it goes a little weird. So I have my A, H, and K. We've seen that it has absolute value bars. So we're going to make our parent table. It's the one with those basic 5 x values. The parent function is always going to be whatever this expression is with no numbers. So the only thing in there without numbers is my absolute value of x. The simplest of simple simples. And it's the same parent table from yesterday, where we've picked the x's to find the y's that give us a good view of that middle. Negative 2, negative 1, 0, 1, and 2. Absolute value of negative 2 is positive 2. Absolute value of negative 1 is positive 1. Absolute value of 0 is 0. Absolute value of 1 is 1. And absolute value of 2 is 2. If we have to think through that every time, it's totally fine. It's still going to be less work than plug and chug guessing into the whole big equation. So you don't have to memorize the parent function if you know how to build the parent function. From here, we are going to build our transform function. This is the one we care about. where we're going to take our x values from the parent and add h. And we're going to take the y values from the parent times a plus k. And again, x plus h, y a plus k, we're going to use all year long. So specifically for this one, I'm going to take my x values from here and add 1. So we're adding 1. So negative 2 plus 1 is negative 1. Negative 1 plus 1 is 0. 0 plus 1 is 1. 1 plus 1 is 2. And 2 plus 1 is 3. For our y values, what we're going to do is we're going to go times 3 plus negative 2 or minus 2. So we're going to take each of our y values from our parent function times a, which is 3, plus k, which is negative 2. So times 3 minus 2. So 2, whoa, that's not a laser pointer. 2 times 3 gives me 6, minus 2 gives me 4. Okay? Do that again. 1 times a times 3 gives me 3, minus 2 gives me 1. Negative 1, positive 1. 1 times 3 is 3, minus 2 is 1. 0 times 3 is 0, minus 2, negative 2. 1 times 3 is 3, minus 2, 1. And 2 times 3 is 6, minus 2 gives us 4. So this one's a little bit more calculatory, but this is still less work than guessing and plugging it in. Okay? So it's the shortcut, easy, gonna use it a gazillion and a half times way we're gonna graph for a lot of things. A lot of things. We're gonna use a, h, and k for every type of function we use this year. We're going to use it for u's, which is our parabolas, our x squared. We're going to use it when things start to go a little wonky and we have stuff that looks like this, or when we have stuff that looks like this, or when we have stuff that does both at the same time. We're going to use a, h, and k to do this transformation with x plus h, ya plus k every time for every kind of function at least once. So what we do from here is we plot up our points and connect them up. So we got negative 1, 4, 0, 1, 1, negative 2, 2, 1, and 3, 4. And we can see here, if we look at our a, h, and k and think through those transformations, a of 3, a is bigger than 1, so it gets up in this big stretch. Oh, and it stretches up this way, nice and big and tall, like it's doing yoga. Because my A is bigger than 1. There's a great big stretch up. So this is vertically stretched. H of 1 means it went right 1, which it did. K of negative 2 means it goes down 2. So we can see all those transformations here on this graph and use that kind of double check that we did it right. What's up? Why is it negative 2 and 1? Because we took our 0 from over here. So from the parent, times 3, 0 times 3 is 0, right? Because anything times 0 is 0. Minus 2, minus k. And it's always going to be, wherever this bounces, at the point H, comma K. H, comma K, that is that vertex point on a parabola. It's that bounce point on an absolute value. It's that point we looked at when we were describing them on those first two that we did today. What? It's H and K. And you should, when you do the table, always wind up with H and K right here in the middle. This is H, this is K. They're always there. So if we've done it right, you will get H and K in the middle of your table. Good question. Ready to do one more like this? Oh no, fractions. It's okay, you can do it. Same process. I'm gonna start with identifying A, H, and K. This time I want us to describe our transformations first, and then we'll hop into our table. So what do we have? I'll make it so you can actually see the equation here. There we go. F of x equals negative 1/2 absolute value of x plus 1 plus 3. And we need to find a, ooh, that is too chunky a pen. Whoa, sorry. Tried to change pens and it changed the whole dang screen. We need to find our A, we need to find our H, and we need to find our K. What do we have? H is, I heard both. I heard H is negative 1, and I heard A is negative 1/2. What's our K? 3. What does this mean? A of negative 1/2. What's happening? Compressed, because it's so little and cute. I want to squish it. And it's reflected over our x-axis. Since that A is negative, it's going to be upside down. What's our H doing? Left 1. And our K? Up 3. Same process we did before. We're getting our parent. Which the parent is the absolute value of x. Oh, I made that very skinny. And it's exactly the same as the one we had before. Negative 2, negative 1, 0, 1, and 2. My y's are 2, 1, 0, 1, and 2. Same parent function that we've had before. Each kind of function that we have is going to have one parent table. Then we're going to come make our actually graphing it table. We do our x plus h, y times a plus k. So x plus h is going to be our easiest one. Negative 2 plus negative 1. We're adding negative 1. Negative 2 plus negative 1. Negative 3. That's I owe you $2 and I borrow another $1. Negative 1 plus negative 1. Negative 2. 0 plus negative 1 is negative 1. 1 plus negative 1 is 0. And 2 plus negative 1 is 1. For our y's, it might be easier sometimes to type these in a calculator. Because this one is going to feel a little bit more like the stuff we did on that first time when we were guessing in check-in. Because we're taking our y values, y times negative 1/2 plus 3. So we're going to have 2 times negative 1/2 plus 3. What is 2 times negative 1/2?
1.
Negative 1 plus 3. 2. 1 times negative 1/2. Negative 1/2 plus 3. 2.5 or 2.5. I genuinely do not care if you do decimals or fractions, whichever one your brain likes better. You're either going to like 2.5 or 2.5 better. And I don't care which one it is. And you can mix and match. 0 times negative 1/2 plus 3. Boom shakalaka. So now we're into this one down here. 1 times negative 1/2. Negative 1/2 plus 3. 2.5. So we're at 2. I'm going to mix my notation. It genuinely does not matter. I can make both choices in the same table, and it is still right. 2.5 and 2.5 are exactly the same thing. So then our last one, 2 times negative 1/2 plus 3. 2. Helps if I use a pen, not a laser pointer. Okay? So it gives us our points to plot, even if they're fractiony or decimally. This is easy to type in our calculators. This is significantly less easy to type in our calculators because calculators don't know how to absolute value. But this they know how to do. So we're going to plot our points. Negative 3, 2. Negative 2, 2.5, and we're estimating. Negative 1, 3. 0, 2.5, and 1, 2. And we can see that V shape and our transformations. That it has been squished, it's compressed, somebody sat on it, it's flipped, it's been reflected over the x-axis, it is left 1 and up 3. So this one had a lot of pieces on it. A lot of different pieces on it. But it's the same exact operations we did yesterday, just messier. Because they're all at the same time. Okay? So graphing with x plus h, y plus k is going to be something we do a gazillion times. And it's barely an exaggeration. Like, we going to do it enough times. Okay, over the course of the next year. Questions on these graphing things? Okay. The backside of homework 1-7, which is the one you got yesterday, has 2 just like this. So you can finish that out. When you finished homework 7, go work on Alex on your pathway. I did not put up a new assignment up today on Alex because I would really like for you guys to work in the pathway a little bit sometimes. Yeah, I think it's called the pathway. Okay? Our next quiz is going to be on Wednesday. I will have a review for you on Monday. Okay? So quiz is next Wednesday. We'll get the review on Monday. And we'll be ready to rock and roll. Y'all have 20 minutes. That's enough time for you to either finish the homework or work on Alex or both. And that is not how we spell Alex. This is Alex with a K. There we go. Alex.